AB Calculus AB, Unit 10, Day 2, Office Hours. These are the answers, the setups with the decimal answers from your calculator. 3 decimal actually required, rounded or truncated. I'm going to show these answers real quick. You can pause the video if you need to. So go ahead and pause it if you need to, and then I'm going to keep going. Here's the next ones. Pause the video if you need to. Here's the next ones. And the last ones. The very last one, there's no real calculation. You're just setting it up with the names of the functions. All right, let's try these out. Now, you were allowed to just use a calculator if you want, but I went ahead and did them by hand also. So I'll do that. You could do that for extra practice. This first one, I would draw a slice, is a square. So we're going to find the volume with some similar, some cross section in terms of x. This whole sheet was in terms of x. So it is going to be a square, and so it's going to be side squared. Now the sides are actually going to be equal to the y value along the curve. So it's going to be y squared. We do need to get it in terms of purely x. So y is x squared. Now be careful here. There's an x squared inside the squared. Now the limits are 0 to 6. So we're going to have 0 to 6 of x to the 4th dx. Now you can put this in your calculator to get the answer, which I'll show you in a second, but we could also work it out by hand. X to the 5th over 5, 0 to 6. 6 to the 5th, some big number. That term's going to go away, so I guess we'll be trying to figure out what 6 to the 5th is. So 6 times 6 is 36, times 6 is 216, so it's going to be 36 times 216. So that's 36, carry the 3 to 6 is 9, 12, 0, 18, carry the 1 to 3 is 4, 6, 17, carry the 1 to 6 is 7. 7, 7, 7, 6 over 5. Nice big answer. Now, I guess if we want to write as a mixed number, we could do some more math. Let's figure out how many times 5 goes in. So you could also write this as 1,555 and 1/5. Or 1555.2. Now on our graphing calculator, I'll try this out real quick. I would just go math 9 and I put x to the 4th, comma x, comma 0, comma 6. And if you're allowed to use a calculator, you want to use a calculator. So we could say the answer is, now to communicate my desire for 3 decimal accuracy, not to make them think I messed up, I'm going to put an extra couple zeros after the 2, even though that is the exact answer. Okay, next one. These cross sections are equilateral triangles. So I'm just going to draw one equilateral triangle. So the volume is going to be some formula for area in terms of x, which is going to be an equilateral triangle, which is going to be, now if you can memorize it, but we don't use this that often, so I think you're maybe more likely to mess it up. It's root 3 over 4 side squared. An equilateral triangle has equal angles also. And so if you draw the height in, it cuts it in half, and you get 30/60 in a triangle, so you get s over 2, and then you get s over 2 times root 3. And so if you just do 1/2 base times height, you're going to get 1/2 times the base is s, and the height is root 3s over 2, and then that gives you root 3 over 4 sine squared, if you had to. Now, the sides are actually equal to the y value of the curve, right? So this is one of the sides, which is really just the y value along that curve. But we do want to get in terms of purely x. So y is equal to x squared. So this is our setup that we're going to put in our calculator, which you always have to show. We're going 2 to 6. It's going to be x to the 4th. So this is our setup this time. And then you plug in your calculator, or we could go ahead and challenge ourselves to see if we can do it by hand. So, I mean, I think we're getting the same big number we got last time. So I guess we could take advantage of that. It was 7.776 root 3 over 20 minus, if you plug 2 in, 2 squared is 4, the third is 8, fourth is 16, 32 root 3 over 20, which would give you, let's just make sure we did this right, 7776 minus 32 would be 4477. So we would get 774 root 3 over 20. We could reduce it, divide a 2 out of it. What would that be? Or, yeah, I don't know. We could divide a 4 out, I think. So we could do 7744 divided by 4. 1, 9, 3, 6. So that'd be 1936 root 3 over 5. So that's your exact answer. On your calculator, we would do math 9. And we would say, actually I do the square root of 3 divided by 4 in front, and then math 9. And you can do it all at once, or you can do it in separate pieces. X to the 4th, comma x, comma 2, comma 6. And we get 670.650. Now, what we do is we check our other answer and make sure that our exact answer by hand is correct. It is. Yeah. So there you go. Let's see. Next one, cross sections are semicircles. So I'm going to draw one. Okay, so the volume is going to be some area in terms of x, because we're doing vertical slices. It's going to be half of a circle, which is going to be 1/2 pi r squared dx, but we need it in terms of all. Can move the pi over 2 out in front. We need it in terms of x's. So going 0 to pi, and the radius, this is the diameter, so the radius is half of that. So this gives me the y value along the curve divided by 2 squared. Again, we need this in terms of x though. So we can write pi over 8 now in front, square root of 2, 0 to pi. The y value is sine x. Now, you guys don't know how to integrate sine squared. But in Calc BC, we use a identity for sine squared. Sine squared is the same thing as 1/2 minus 1/2 cosine 2x. So we're using a double angle identity for cosine, which can be written in terms of sine squared, to get something that we can actually integrate. Now, if you're going to integrate this, we're going to do pi over 8 All right, so anyways, yeah, you guys don't. It's a trig identity, so it's but we encounter this a lot in Calc BC. It's gonna be x over 2 minus, now the antiderivative cosine is sine, but it's going to give you an extra, we have a 1/2, but this is going to give you an extra 2 in front that we don't want, so we need another 1/2. That's a chain rule. You can do U substitution to pull that off. Or if it's just a number like that, I usually just do it in my head. So we're going to get pi over 2 minus 1/4 sine of 2 pi is 0. Then we plug 0 in, we're going to get 0 over 2 minus 1/4. Sine of 0 is 0. So those cancel out, and we get pi squared over 16. This was our setup. So you don't need to use the trig identity to do it on your calculator. Your calculator can do all these for you. So let's check our answer. Or just do it. Pi over 8, math 9, sine x close squared, comma x, comma 0, comma pi. And the answer we get from the calculator is 0.616 or 0.617. And let's check. Pi squared divided by 16 is the same thing. So that's good. Okay. Next one, vertical slices are squares. Okay, so that's one slice. So the volume is going to be some area formula in terms of x. It's going to be a square, which is going to be side squared, which is going to be y top minus y bottom in terms of x. And we also need to find the intersection of these. Move everything to one side, equal to 0, factor it, and we get x equals 0 and 1. So this is x equals 0, the y is 0, and this is x equals 1, the y is 1. So we're going 0 to 1. Y top is the square root of x. Y bottom is x squared. And then it's squared, of course. So that's your setup for your calculator. Now, if we're going to do it by hand, we're going to want to FOIL this out first. Now, on a calculator, you don't need to do this. You FOIL it out. And so then we're going to get 0 to 1, we're going to get x. Then we get x to the 5/2 twice, so minus 2x to the 5/2 plus x to the 4th. And so then now the antiderivative is going to be x squared over 2 minus 2x to the 7/2 divided by the new exponent plus x to the 5th over 5. 0 to 1. Okay, so we'll plug 1 in, we get 1/2 minus 4/7 plus 1/5. Plug 0 in, you get 0 minus 0 plus 0. Least common denominator would be 70. So we give every one of those that. And then so we have 35 minus 40 is -5 plus 14 is 9/70. That's the exact answer. Now, on our calculator, let's see, let's just do it on our calculator. I'm going to do math 9, and I'm just going to put this one in here. So it's going to be parentheses. You got to add those extra parentheses. Square root of x, close parentheses on the square root, minus x squared, close parentheses on all of that. Remember the squared, comma x, comma 0, comma 1. And the answer from our calculator is 0.128. or 0.129. Let's check. Is that the same thing as 9/70ths? It is. Good sign. Okay. Next one, cross sections are equilateral triangles. Let's draw one of them. In the future, you guys are probably going to have to draw these graphs first yourself. I'm going 0 to 4. So we're doing some volume. Area in terms of x, common area, common shapes. It's going to be equilateral triangles, which, like we said before, you can memorize this, root 3 over 4 side squared, or you could rederive it, you know. Now the sides are going to be y top minus y bottom, y top minus y bottom. And then in terms of x, so you can move the root 3 over 4 out front. We're going 0 to 4. So y top is x plus 2, y bottom is negative x squared. So that's your setup for your calculator. Don't forget this squared. Now if we're going to do this by hand, we would want to FOIL this all out. I mean, it's a lot quicker by calculator, but if you're getting some extra practice like I am, now I would just plug it in your calculator like this if you can do it by calculator. So I'm going to say 0 to 4. I'm going to get x squared. Oh, this is going to be a mess. X squared plus 2x plus x cubed plus 2x plus 4 plus 2x squared plus x cubed plus 2x squared plus x to the fourth. Oh my gosh. Combine like terms. Probably put the x to the fourth first, and then 2x cubed. And then we have x squared, 2x squared, 2x squared. So is that 5x squared? And then x is 2x, 2x, 4x, 4x, and plus 4, I think. Okay. Yeah, this is not. The integers would be x to the fifth over 5 plus 2x to the fourth over 4 plus 5x cubed over 3 plus 4x squared over 2 plus 4x, 0 to 4. Oh my gosh, I don't even know if I want to do this. I think I'm going to bail on this. Yeah, I think I'm going to bail on this. The answer, I'll tell you what the answer is. If you make it through, it's 1828 root 3 over 15, which is 211.079 as a decimal. Let's check it on our calculator. Math 9. I'm going to do the root 3 over 4 first, then math 9, and then parentheses x plus 2 plus x squared, close it squared, comma x, comma 0, comma 4. There's the answer, 211.079. Same answer, way faster. So if anything, you should also be appreciating your calculator. But yeah, I mean, if you were to keep going with this, it's just kind of a mess for the 3 over 4. Put 4 in this, that's 1664, 256 over 5 plus, is that even right? No, I think it's even bigger than that. It's 1024, then plus 256 over 2, and then plus 64, 320 over 3, and then 1632, and then 16, and then you plug 0 in, and it's going to be 0 plus 0 plus 0 plus 0 plus 0. And then you got to work on cleaning this up. So anyways, all right. To the back. Okay, onto the back. So this one, they're semicircles. All right. And so we do volume equals area in terms of x dx. And they're going to be half circles. So it's going to be 1/2 pi r squared dx. So this is going to be y top minus y bottom. So we move the pi. Now that's the diameter. We're going 2 to 8. So the diameter is y top, which is square root of x. Y bottom is negative x cubed divided by 2 squared. So we could write this as pi over 8, 2 to 8, square root of x plus x cubed squared dx. So that's your setup for your calculator. If you're going to do it by hand, it'd be x to the 1/2 plus x cubed, and then you would FOIL it out. FOIL it out. It's going to be pi over 8, 2 to 8. It's going to be x. That's going to be 7/2, 2 of them, plus 2x to the 7/2, plus x to the 6th. And then we could work it out by hand. Pi over 8. Antiderivative is x squared over 2 plus 2x to the 9/2 divided by the new exponent plus x to the 7th over 7. 2 to 8. I think I'm tempted. Well, I mean, I'll write it as much as I can. Pi over 8. It's going to be 64 over 2, which is 32. 4/9, square root of square root of 8 is 2 root 2 to the 9th power plus 8 to the 7th over 7. Minus, you plug 2 in, you get 2 plus 4/9. Square root of 2 to the 9th power plus 2 to the 7th over 7. I'm not going to show any more simplification. I'm just going to let that go. All right. So on our calculator, pi over 8, math 9, and parentheses, extra parentheses, square root of x, close parentheses and square root, plus x to the 3rd, close parentheses on all of that. Make sure you square it, comma x, comma 2, comma 8. So this is the answer, 119,672.608 rounded truncated, comes out the same thing this time. Big answer. All right, next one. Let's see. Cross sections are getting a little more complicated. So it's going to be square with half of a circle on the top. So the volume is going to be some area in terms of x dx. And so it's going to be a square plus half a circle. Right, so it's going to be side squared plus 1/2 pi r squared. We probably want to try and get this in terms of, this is the side of the square. So we could either say the side equals 2 radiuses, or we could say the radius equals half of a side. I think it would be better to go with the radius equals half of a side. So it's going to be side squared plus 1/2 pi side over 2 squared. All right. And so we're going from 2 to 4, and the sides are going to be the y value of this curve in terms of x is x squared plus pi over 8, and then the side is going to be x squared. So we're getting close to it. I mean, I guess that could be your setup, but you can simplify this a little bit, which would make it easier to type in anyway. So it'd be x to the 4th plus pi over 8x to the 4th. So this is what you could enter in your calculator. That's your setup. If you do by hand, what we could do is we could factor the 1 plus pi over 8 out and do it like this. Cuts down on the terms. So the antiderivative is going to be x to the 5th over 5, 2 to 4. So that's going to be 4 times 4 is 16, 64, 256, 1024. And that's going to be 8, 16, 32. All right. And we could take it further. So 1024 minus 32 is going to be 992 over 5. So I mean, this could be our answer. We could distribute 992 over 5 plus 992 pi over 40. We could probably reduce that if we wanted to. You know, like 8, obvious 8 might go into 992. Actually, I don't know. Let's see, 992 divided by 8. Okay, so we could say 992 over 5 plus 124 pi over 5. Anyways, on our calculator, let's try this out. We go with this. We go with math 9, x to the 4th plus pi over 8, x to the 4th, comma x, comma 2, comma 4. That's what we get. Let's check our other. So 992 divided by 5 plus 124 pi divided by 5. Hey, same answer. 276.311. Round truncated comes out the same this time. All right. Okay. Getting close. These are going to be a square, an equilateral triangle on the top. So we're trying to find volume. Common cross section in terms of x. It's going to be a square plus an equilateral triangle. It's going to be side squared plus root 3 over 4 side squared. And they are the same sides, so go with that. The sides, though, are y top minus y bottom. That's a side. Now, to clean this up, make this a little easier, I could factor out a 1 plus root 3 over 4 because they both have side squareds. And leave the side squared in here. Now, the side squared is going to be y top, which is x squared plus 1 minus y bottom, which is x squared dx 0 to 1. So this is your setup for your calculator. You can just put that in your calculator. If we're going to do it by hand, because we like to do all this extra work, we would have to FOIL this out, which is going to be, well, it's going to be a good fair amount of terms. So it would be x. It'd be x to the fourth plus or minus x cubed, another minus 2x cubed, and then you get an x squared. Another. All right, this is too hard to do on my head. Forget it. Minus x cubed plus x squared minus x cubed plus x squared minus x plus x squared minus x plus 1. So we have x to the fourth minus 2x cubed x squared plus 3x squared minus 2x plus 1. Nice. Okay. So the antiderivative is x to the fifth over 5. And luckily, the numbers that we're going to plug in are going to be super simple. 2x to the fourth over 4 plus 3x cubed over 3 plus 2x squared over 2 plus x. Those cancel. That's a 2. We're going 0 to 1. So we plug 1 in, you get 1/5 minus 1/2 minus 1 minus 1 plus 1. Plug 0 in, you get 0 minus 0 minus 0 minus 0 plus 0. So 2 of those cancel out. Least common denominator would be 10. So okay, what do we got here? We got 2 minus 5 is negative 3, negative 13. It doesn't make sense. It shouldn't come out negative for sure. For sure, should not come out negative. I think I made a mistake here. That's a plus. So this one's a plus. Makes more sense. Shouldn't get a negative answer for volume or area. Something's wrong for sure if you did. So I caught my mistake. This is going to be 12 minus 5 is 7 tenths. So, I mean, we could say that's the answer. We could distribute it 7 tenths plus 7 root 3 over 40. And we can check it on a calculator. So let's try this. Parentheses 1, you didn't have to factor stuff out, but it does make it quite a bit simpler to type in. Makes it simpler typing it. Or so we put parentheses around all that, and then we do math 9 parentheses x squared plus 1 minus x close squared comma x comma 0 comma 1, and we get 1.003 round check to 3 decimal place, same thing. So let's check out the answer. 7 tenths plus 7 root 3 over 40. Didn't type in something right. Put same answer. Looks good. Okay, last one. We don't actually have real functions, but we're going to take it as far as we can. Okay, so the volume is going to be some area in terms of x dx. It's going to be a square minus half of a circle. So it's going to be side squared minus 1/2 pi r squared. We would like to get these in terms of both r, both s. I think s is going to be the way to go. S equals 2r, r equals 1/2 s. So it's going to be side squared minus pi over 2 side over 2 squared. Okay. And then that's going to give us side squared minus pi over 8 side squared. So we could do that trick that I've shown you in the last couple. Since they're both sides squared, factor out the 1 minus pi over 8. Now, we're going from A to B. The sides right here are y top minus y bottom. Now, y top, in terms of x, is f of x. Y bottom is g of x. squared dx. There you go. That's as far as we can take it. Can't do anything, you know. You could have left the side squareds in there and your answer would look like this. You would say, okay, well, here's a side squared, which is me fx minus gx squared minus pi over 8. And then I have another side squared, which is me y top minus y bottom, which is me f of x minus g of x squared. Closed parentheses on the whole thing. So, I mean, this is the same thing. It's not as nice, but we can't take any further. That's it. So there you go.